Hello everyone, myself Vinit from Chemistry Honors second year. Today our chapter is Diazonium salts. So let us start the chapter. Diazonium salts. Diazonium compounds or diazonium salts are a group of organic compounds with a general molecular structure Rn2 plus X, where R may be any alkyl or aryl group and X may be halogen, hydrogen, sulfate, etc. Aryl diazonium salts have frequently been used as intermediates in organic synthesis. Nomenclature. Arene diazonium compounds are ionic in nature, that is, they are salts. This is well reflected in their name as they are collectively known as diazonium salts. Thus, ionic compounds containing NN are collectively called diazonium salts and they are named by appending the word diazonium to the name of the name of aromatic compound followed by the name of the anion. Benzene diazonium chloride, p-toluene diazonium chloride are some of the examples. Benzene diazonium chloride can thus be represented by following two electronic structures in which the positive charge is shared by both nitrogen atoms. The relative stability of aromatic diazonium cation may be attributed to delocalization of the positive charge on nitrogen on the pi system of the ring. Synthesis of benzene diazonium salts. Synthesis of diazonium salts. Treatment of primary amine with nitrous acid result in formation of diazonium salts, a compound of the type ArRNN plus X minus, where X is an anion like chloride, bromide, sulfate, etc. But since nitrous acid is unstable, as a result it is generated in situ by treatment of sodium nitrate with strong acids such as HCl or H2SO4. This process of conversion of primary amine to its diazonium salts are called diazotization. NaNO2 plus HCl gives HNO2 plus NaCl. P-toluene plus NaNO2 plus 2HCl at 273 to 278 Kelvin gives p-methyl benzene diazonium chloride plus NaCl plus 2H2. CH3CH NH2 CH2 CH2 CH3 pent 2 amine plus NaNO2 plus HCl 273 to 278 Kelvin gives CH3CH N triple bond NCl CH2 CH2 CH3 plus NaCl plus 2H2. Diazonium salts are aliphatic primary amine are highly unstable even at lower temperatures. As a result, as soon as they are formed, they decompose, liberating nitrogen to form carbocation. The carbocation may undergo substitution and elimination reaction to give alcohol and alkene respectively. As a result, diazotization of aliphatic primary amine is of little or no importance and their reaction are also of no importance. Pentane 2 amine plus NaNO2 plus 2HCl at 273 to 278 Kelvin gives CH3CH N triple bond NCl CH2 CH2 CH3 plus NaCl plus 2H2, which further gives, after the breakdown of the bonds, gives CH3CH plus CH2 plus CH2 CH3 plus N2 plus Cl minus. It will give after elimination reaction it will give pent 2-ene as a major product and pent 1-ene as minor product, and when it goes SN1 reaction it will give pentane 2-ol. Though diazonium salts are primary aromatic amines are also unstable, but they are far more stable in comparison to diazonium salts of aliphatic primary amines, and they do not decompose when the temperature of the reaction mixture is kept below 278 Kelvin. Mechanism. The reactive species of diazotization is nitrosonium cation generated by the reaction of nitrous acid with acid. The electrophilic nitrosonium cation with nitrostates the nitrogen of the nucleophilic amine. After a series of protonic shifts followed by loss of water leads to formation of diazonium salts. NaNO2 plus HCl gives HONO plus NaCl. HONO in presence of H plus gives H2 plus NO. Fast reaction H2 plus NO plus. From the above mechanism, it can be seen that the reaction is dependent on the nucleophilicity of amino nitrogen. If an electron withdrawing group is bonded to the aromatic ring, the nucleophilicity of amino nitrogen is reduced, making it difficult for the diazotization reaction to take place. For example, p-nitroaniline is a weaker base in comparison to aniline because of mesomeric and inductive effect of the nitro group. The diazotization of p-nitroaniline is difficult in comparison to aniline. On the other hand, electron donating group present at ortho and para position to the amino group increases the nucleophilicity of amino nitrogen, thereby increasing the rate of diazotization process. Physical properties. Diazonium salts are generally colorless crystalline compounds which darkens on exposure to air. Many diazonium salts of nitrates and perchlorates when dry, they explode on being heated or being struck. As a result, these salts are not isolated, and soon as they are prepared in situ, they are immediately used for further synthetic preparations. However, double salts are made from diazonium and zinc chloride, and between diazonium and tetrafluoroborates are stable at room temperature, and they have been used as fast dye salts in the manufacture of naphthol AS dyestuffs. Chemical reaction. There are number of synthetically useful reactions of diazonium salts, but a distinction has been made between these reactions on the basis in which the nitrogen atoms of diazonium group are lost and those in which they are retained in the end product. Thus, the useful reaction of diazonium compounds are basically classified into two main groups. Reaction in which the diazo group has been substituted by other functional group, and reaction in which the diazo group is retained. Reaction involving replacement of diazo group by other functional group. Replacement by H deamination reaction. Replacement of diazonium group by hydrogen, thereby effecting the overall removal of amino group, is known as deamination. The diazo group can be reduced by a variety of reagents like phosphinic acid or hypophosphorus acid H3PO2 in the presence of copper, salts, ethanol C2H5OH, triphenylphosphine, formaldehyde HCHO, and by metals such as zinc, Zn, tin, and hydrochloric acid SnHCl, etc. But hydrophosphorus acid remains the most selective reducing agent for deamination since it exhibits a high degree of selectivity for the protonolysis of diazo group in comparison to other groups that may be present on the arene ring. ArN2 plus Cr plus CH3CH2OH when heated gives ArH plus N2 plus HCl plus CH3CHO. A free radical mechanism has been proposed for this reduction reaction with hypophosphorus acid, in which copper ion acts as one electron reducing agent. The overall reaction is basically a two-step process involving diazotization followed by reduction. However, now this two-step process has been replaced by one-pot reaction in which the de-diazotization take place in one step. Applications. The deamination of amines offer a useful method for the synthesis of trihalogen arenes, which otherwise cannot be synthesized by direct halogenation of arenes. Direct halogenations of benzene would give the monohalogenated product. However, halogenations of aniline, which has an activating amino group, directs halogenation to its ortho and para position. Removal of the amino group gives the desired product. Similarly, it is not possible to synthesize meta derivatives of arenes having ortho-para directing group. For example, it is not possible to obtain meta halogen derivative of toluene because methyl being ortho-para directing group, it will always give mixture of ortho-halo-toluene and p-halo-toluene. However, bromotoluene can be synthesized from p-toluidine or directly from 2-bromo-4-methyl aniline in the following manner. Similarly, M-nitrotoluene can be synthesized from 4-methyl-2-nitroaniline. Replacement by hydroxyl group. Hydrolysis of arene diazonium salts. This is a more versatile method for the synthesis of phenols as the conditions required for carrying out the reaction are very mild. Aniline or its substituted derivatives on reaction with sodium nitrite and hydrochloric acid, sulfuric acid at lower temperature are converted to diazonium chloride sulfate, which on hydrolysis with water or acid or heat yields phenols. Replacement by halogens. Replacement by ClBr, Sandmeyer reaction. Diazotization or primary aryl amines with nitrous acid followed by treatment of aryl diazonium ion with cuprous chloride, cuprous bromide yields the corresponding aryl chloride, aryl bromide respectively. Getterman reaction. This reaction named after German chemist Ludwig Getterman is originally used for synthesis of aromatic aldehyde, but synthesis of aryl halides from diazonium salts are also included in this reaction. The reaction is a modification of Sandmeyer's reaction, and instead of cuprous salts, finely divided copper or copper bronze is used for the decomposition of diazonium salt solution. Replacement by fluorine. Bals-Scheiman reaction. Diazotization of primary aryl amine with nitrous acid followed by treatment of synthesized diazonium salt with fluoroboric acid yield aryl diazonium fluoroborate salt. The mechanism of reaction is believed to proceed with the decomposition of aryl diazonium fluoroborate to aryl cation intermediate with intermediately forms aryl fluoride and boron trifluoride by reaction of the aryl cation with tetrafluoroburate. Replacement by iodine. Replacement of diazo group by iodo does not take place with the aid of copper iodide as catalyst as it is not soluble in water. The iodo group is however introduced by warming the diazonium salt solution with potassium iodide or a solution of iodine and potassium iodide. Orthotoluidine in presence of NaNO2 HCl gives iodotoluene when reacted with Ki or I2 or Ki. Replacement by cyano group. The replacement of diazo group by a cyano group is special case of Sandmeyer's reaction, often referred to as modified Sandmeyer's reaction. The reaction involves treatment of diazonium salt solution with a solution of copper cyanide in aqueous potassium cyanate. Replacement by aryl group. A number of methods are available in which the diazo group is replaced by an aryl group. Gomberg-Bachmann reaction. The reaction involves treatment of diazonium salt with an arene in the presence of dilute sodium hydroxide. The product of the reaction are biaryl derivatives. Score reactions. The reaction chiefly accounts for the synthesis of phenethylene or its derivative via diazotization followed by intermolecular ring closure process using copper. Mervyn arylation. In this reaction, addition of aryl diazonium salts to an alkene which is bonded to an electron withdrawing group like COH, COOR, NO2, etc. in the presence of copper salt take place. When the double bond is presented adjacent to the carboxylic group, then sometime the arylation as well as decarboxylation reaction take place simultaneously. Replacement by arsenic group Bart reaction. The reaction named after H. Bart, German patent 250264, 1910, is a reaction of diazonium compound with alkali arsenate such as sodium arsenate in presence of copperic salt or powdered silver or copper powder, resulting in the formation of aryl arsenic acid. E. Scaler, however, improved the Bart reaction and carried out diazotization of primary amines in presence of arsenic chloride with traces of cuprous chloride. Replacement by thiol group. Thiol group is introduced by treating the diazonium salt with potassium ethyl jethate followed by hydrolysis. Replacement by nitro group. Nitro group is introduced by treating arene diazonium fluoroborate with an aqueous solution of sodium nitrite in the presence of copper powder. Reaction in which nitrogen of diazo group is retained. Reduction to aryl hydrazines. Aryl hydrazines are synthesized by reducing diazonium salts with diazonium sulfide or stannous chloride followed by acidification with hydrochloric acid. The hydrochloride derivative crystallizes out on cooling, which on treatment with sodium hydroxide liberates the free hydrazine derivatives. Coupling reaction. Coupling reaction are those in which the diazonium salts are linked or coupled with another molecule. The amine that is to be diazotized is referred to as diazonium component, and the compound with which it is linked is called coupling component. The whole reaction is commonly called as azocoupling. Diazonium salts being weak electrophiles, as a consequence they react with those aromatic systems which are activated by strong electron donating group. It is for this reason diazonium salts usually undergo coupling reaction with phenols and aromatic amines in alkaline, neutral or mild acidic medium to yield highly colored azo compounds. This type of coupling is often referred to as C coupling. Coupling with phenols. Coupling of diazonium salts with phenols is usually carried out in the pH range of 8 to 11, and in this pH range the phenols are usually present as phenoxide ion. Coupling with amines. Tertiary amines react with diazonium salts in a similar manner as phenols, except that the coupling reaction is carried out in slight acidic medium. Coupling of diazonium salts with primary amine radially takes place at the nitrogen of the diazonium ion in weakly acidic medium, leading to the formation of diazoamino compounds. This type of coupling is referred as N coupling. The formation of diazonium diaminobenzenation takes place under acidic condition, then it undergoes rearrangement to p-aminoazobenzene. Alternatively, rearrangement can also take place by heating below 50 degree. Diaminoazobenzene in aniline with aniline hydrochloride. When the para position is blocked, then the rearrangement takes place at ortho position. Like primary anilines, coupling of diazonium salts with secondary amines also take place at the nitrogen of the diazonium ion. The diazoamino compounds, as soon as it is formed, immediately rearranges to azo compounds. So this was our chapter diazonium salts. Thank you.